A submarine moves out from its base. It may be on routine patrol or on a highly specialized mission. Aboard is a full complement of trained officers and men with all equipment and supplies necessary for the completion of their mission. Submarine warfare involves worldwide operations. These underwater warships go farther and remain longer in enemy waters than any other force. Away from their bases, they are more on their own than any other military force. But this is possible only with adequate support operations. Behind every submarine is a command and an administrative organization especially adapted to undersea warfare, essential to the support and combat efficiency of the operating submarine. It is responsible for training and assignment of personnel, planning new installations, repairs, tests, and maintenance for logistics. A complete supply system designed to meet the specialized and diverse needs of submarines. Bases are located at New London, Key West, Balboa, St. Thomas, San Diego, Pearl Harbor, Midway, Guam, and Subic Bay. In addition, there are advanced bases to which goes much of the credit for the submarine's ability to move across vast reaches of ocean to fight. Here are located the floating dry docks and the submarine tenders. An average wartime patrol lasted about 2 months and covered as much as 16,000 miles. On such patrols, the submarine's crew and machinery were subjected to the equivalent of 1 year's routine peacetime wear and tear. After each patrol, approximately 1 month was required for overhaul. This time was used by the crew for rest and recuperation. Each wartime division of 6 submarines is assigned a division relief crew, which is the equivalent of 2 1/2 boat crews. When the submarine puts into dry dock, these men repair the underwater gear, the rudder, the diving planes, and torpedo tubes, while the operating crew is resting. Repairs in dry dock normally require 4 or 5 days, and then the submarine is moored alongside the tender. The relief crews work around the clock, making repairs and loading stores. By this method, one division of 6 submarines can maintain 2/3 of its force at sea. That is, 2 on patrol station, 1 on the way out, and 1 on the way in, while 2 more are in refit status. In peacetime, the speed of this cycle is slower, and the submarine's own operating crew takes over the wartime relief crew's job. This is part of the vast undertaking that comprises the support operations that keep the United States submarine forces in fighting trim. But basic to all these operations is the thorough training of personnel. From the operating fleets and service schools come the men who volunteer for submarine service. Medical specialists learn as much as possible about each man, his physical condition, basic abilities, and also his personality, because in a submarine, men are confined in a small space for many weeks, and they must get along with each other. There is no room in a submarine for petty feuds. There is also no room for carelessness. Since one mistake can result in disaster, thoroughness is an absolute must. Submariners must have the ability to cooperate and to be alert both their own duty and to anything that needs attention. To decrease the hazards of submarine duty, men are trained in escape techniques. As a first step, they are trained in an air chamber where underwater pressure conditions are simulated. As a next step, they go to an escape training tank where escapes are made from gradually increasing depths until men are able to come up safely from 100 feet below the surface. This is just one of many training installations at the New London submarine base. Here there is a multiplicity of equipment and mock-ups used for the demonstration of submarine construction and operation. With these, it is possible to study every part of the submarine from the keel up. They reproduce details of every compartment and every piece of machinery. On a diving trainer, it is possible to simulate full-scale submerged operations in those phases of operation which make the submarine what it is. They are learning to take her down, to cruise submerged. They learn to transfer ballast, to control depth, to operate the vents, and they learn to bring her to the surface. Duties are rotated because every man aboard a submarine must be able to man other stations in addition to his own. And here seagoing operating conditions are duplicated exactly. Of all warships of the naval forces, the submarine is most likely to encounter problems of repair at sea. Alone and unassisted on missions requiring as long as 60 days, it frequently requires major engine repairs at sea. Therefore, repair techniques are practiced and learned in the engineering department on a life-size diesel. On the surface, a submarine is powered by 4 of these 1,500 horsepower engines. Since the submarine can run on any one or any combination of the 4, the engine needing repair can be taken off propulsion at any time. In a submarine crew, approximately 1 out of every 4 men is an electrician. To train these men, all basic circuits are reproduced in accurate, realistic mock-ups. Here is the control cubicle. There are 347 separate electrical circuits to main motors, generators, and batteries. The elaborate and complex system of auxiliary machinery must be completely powered electrically. Electricians are key men. Because a depth charge may compel anyone to man his station in darkness, men are trained to perform vital operations blindfolded. For the same reason, damage control is doubly important on a submarine. In fact, all submarine duty is highly specialized, requiring specialized training. Yet, at the same time, it requires extreme versatility on the part of the individual. Because all the basic functions of a major warship must be performed by a submarine with extremely limited personnel and equipment, each man must know more than one job. The ship's cook may have to learn radar operation, and the torpedoman may have to learn to operate the sonar. The submarine's navigational problems are complicated by the necessity of operating at depths where current effects are not known and the usual landmarks are not available. To teach torpedo approach and attack, one of the Navy's most elaborate training devices is used. A complete conning tower with periscopes and all associated instruments and controls permits each operator to make an approach using all of his knowledge, skill, and judgment. On the attack teacher, the approach and torpedo firing can be simulated with a high degree of realism. Target ships are moved electrically. This area represents 16,000 yards, the approximate maximum distance at which ships are likely to be sighted through the periscope while submerged. As the attack progresses, the situation is shown on a plot not visible to the control party in the conning tower below. Through the periscope, the approach officer sights the target, gives the bearing, angle on the bow, range, and calls an order conning the submarine to close the target's track. The approach officer has taken one bearing, and after a few minutes he puts up the scope and takes another. He is trying to determine target course and speed. It looks as though the approach is going to be successful. Successive bearings are enabling him to maneuver onto the target's track, ahead of the target itself. And he's made it. He has solved the target's course and speed. His bow tubes are ready. The approach officer is having another look. He appears somewhat excited. The target has changed course. He calls for left rudder in a desperate attempt to close the new track and get into position for bow shots. But the target is too fast, and the torpedo passes astern. He should have swung right for stern tube shots.